We are in section 11.2, which is on contingency tables. In this section, we use standard statistical methods to analyze frequency counts in a contingency table or a two-way frequency table. A contingency table or a two-way frequency table is a table consisting of frequency counts of categorical data corresponding to two different variables. We have a test of independence. We test the null hypothesis. In a contingency table, the row and column variables are independent. That is, there is no dependency between the row variable and the column variable. The idea behind testing these types of hypotheses is to compare actual counts to the counts we would expect if the null hypothesis were true. The variables are independent. In a chi-squared independence test, the null and alternative hypotheses are always going to be H0 is the variables are independent, and H1, our alternative, is going to be the variables are not independent or dependent. So steps for determining the expected counts in the test for independence with the TI-8384 calculator. So this is set up way differently than any of the testing that we've been using so far. So the first thing is we need to use a matrix, and a matrix is almost like an Excel spreadsheet. It organizes variables into rows and columns. And so we are going to go on our graphing calculator. We're going to go to second x inverse, which is matrix, edit. We're going to select enter on matrix A, and we're going to enter our rows and columns. They don't include the totals. So we're going to enter in our rows and columns, and that's how we describe a matrix, is by rows, by columns. And we're going to enter the data value into the matrix. Then we're going to go second mode, which is quit, which gets us out of that matrix. And step 2 is going to be, we're going to go to our chi-square test, which is going to go stat, go over to test, go down to chi-square test. Matrix A is where we put our observed data. After we run the test, we will get our matrix B. So right now you should have no values in there for B. You're going to calculate and select enter. Step 3 is second x inverse matrix. B, hit enter, enter, and those are going to give you guys the expected counts or the expected frequencies. So that's where our matrix is. So the first example on here says a sociologist wants to discover whether the sexual activity of 15 to 19-year-old females and family structure are associated. She randomly selects 380 females between the ages of 15 and 19 years of age and asks them to disclose family structure at age 14 and whether or not she's had sexual intercourse or not. The results are shown in the table below. Compute the expected counts of each cell under the assumption of independence. So in order to do this, we need to put all of our data into matrix A, and we need to use our chi-squared test. And the reason why we know that it's a chi-squared test is because it talks about independence. Okay, in order to do this problem, second x inverse, which is matrix, go over to edit, select enter. The size of your matrix is a 2 by 4. And so you need to type those values in first, and then once you have those, you can enter in all your other numbers. Again, double checking that they are all in correctly. Once you have those numbers in, select second mode or quit to get out of that. And we have to run the chi-squared test. So go to stat, go over to test, and chi-squared test, select enter. Your observed are in matrix A, and I want them to be inputted into are expected into matrix B. So we're going to go down to calculate, enter, and you'll notice you get your chi-squared. That's going to be our test statistic, and P, our p-value, and then degrees of freedom. And for this problem, it's asking for our expected values. Our expected values, again, are in matrix B. So in order to see those, you need to go second x inverse, and you'll notice now you have a matrix B on there. So scroll down to B, select enter, and a B should show up on your screen. Select enter one more time, and then you will see all of those expected values. This is what you would expect to occur, assuming that that null hypothesis is true. So matrix B is our expected counts. And as we saw in the calculator, those values, and I'm just going to go ahead and round them by 2 decimal places for right now. And I'm going to go ahead and write those down. And these are what we would expect to happen if the null was true. And the null being true is that they are independent, that those variables are independent, that they have nothing to do with one another. And I put those brackets around matrix B. That's just how they write matrices. So in order to understand this, we would expect from this study that the sociologist would have determined that had sexual intercourse would be no, and had a single parent at the age of 14 would have been 47.63 females that they surveyed, if those variables were independent. To calculate the test statistic for the test for independence, we're going to let O sub I represent the observed counts for the ith cell, and E sub I represent the expected counts for the ith cell. Then the formula is going to be, and we saw this before in the previous section, approximately follows the chi-square distribution with rows minus 1 times column minus 1 degrees of freedom, where R is the number of rows and C is the number of columns in the contingency table, provided that all expected frequencies are greater than or equal to 1, and that no more than 20% of the expected frequencies are less than 5. So in order to calculate our chi-square test for independence with the TI-83 or 84 calculator, so to test this, first thing is we're going to write down our null and our alternative hypotheses. And so our null is going to be our row variable and column variable are independent. And then our alternative is going to be that the row variable and column variable are dependent. Then we have our level of alpha. Step 3 is to verify that those requirements are met and that this test can actually be conducted. Step 4, we're going to go to stat, test, chi-square test. Again, put our values into A. Go down to calculate, select enter. When you do this, you're going to get an output of values. First thing is going to be the chi-square, which is our test statistic for independence, and also P, which is our p-value, along with DF, which stands for our degrees of freedom. And if the p-value is less than alpha, then we reject our null hypothesis, and then we're going to state the conclusion for the test. So the next example that we have, it says from the previous example, so that we already looked at, and all those values should be still in on your calculator, we need to verify that the requirements for performing the chi-square test for independence are satisfied. So the first thing that we have is that it has to be a simple random sample. And it has to be a two-way table. And the expected counts have to be at least 5. So matrix B, which is where we had our expected counts, are all larger than 5. So that means that we are able to perform this test. So compute the chi-square test statistic, and we saw that previously when we went through that. So I'm going to go ahead and write down our chi-square test, and I'm going to go ahead and round 3 decimal places. So I have 10.357 for my test statistic. And then part C says test whether family structure and sexual activity of 15 to 19-year-old females are independent at the alpha equals 0.05 level of significance. So in order to test this, I need to write down my null and my alternative hypotheses. So H naught, our null, is going to be that family structure, our 2 variables that we're talking about are family structure and sexual activity are independent. And then our alternative hypotheses, H1, is going to be identical to this except for instead of it being independent, they're going to be dependent. So family structure and sexual activity are dependent. Another word you can use is not independent, but I'll say are dependent. And we saw earlier our p-value is going to be 0.0158, which is less than alpha, which was equal to 0.05. And this means we are going to reject our null hypothesis. So in conclusion, there is sufficient evidence at the alpha equals 0.05 level of significance to conclude that family structure and sexual activity of 15 to 19-year-old females are dependent. And D, I'm going to circle and we will discuss that part together. The next test that we have is called the chi-square test for homogeneity of proportions. Test whether different populations have the same proportion of individuals with the same characteristic. The procedure performing the test of homogeneity are identical for those as performing the test for independence that we just went through. So the only difference besides going through with the calculator is going to be our null and our alternative hypotheses are going to be different. So definitely something we need to know. H0 is going to be that the proportions are all the same. And H1 is going to be that at least one proportion is different. So example here says, in a recent survey conducted by the Pew Research Center for the People and the Press, a random sample of adults 18 years of age or older living in the continental U.S. were asked their reaction to the word capitalism. In addition, the individual was asked to disclose what political party they most associated with. Results of the survey are given in the table below. So in order to perform this test, this has to be a simple random sample, which it is. It has to be a two-way table, which it is. And then we can conduct this test and actually see if those expected counts are larger than 5, which they are. So I'm going to go ahead and continue on with this. And the next part of this problem says, does the evidence suggest different proportions of individuals within each political affiliation react positively to the word capitalism? And so we are talking about proportions. We are definitely dealing with more than just one or two proportions like we saw in Chapter 9 and Chapter 8. So we have 3 different groups here. And so we're going to go ahead and say H0 is going to be that the proportions are all the same, which is what we have written up above. And so you can write that in words. It would be by political party affiliation. I'm going to go ahead and write it with symbols. So I'm going to say the proportion of Democrats, D for Democrats, is going to be equal to the proportion of independents. And it's going to be equal to the proportion of Republicans that respond positively to the word capitalism. And I'll go ahead and put a D, an I, and an R above these groups, just so then that way you know what those variables, those letters are standing for. And then we have our alternative hypotheses, which is always going to start off with at least 1. So at least 1. And it's going to be proportion of individuals reacting positively to the word capitalism is different. So at least one is different. So from here, we need to use our graphing calculator in order to get our p-value. So we need to first put our values in to our matrix. So second, x inverse. Go over to Edit, select Enter on A, and our matrix this time is a 2 by 3. So change its size to a 2 by 3 and enter all your values in, checking to make sure you inputted those in correctly. Next thing is we need to exit this mode, so hit second mode, which is quit, and then go stat, and we have to do our chi-squared test, so go over to test, go down to chi-squared test, select enter. Your observed counts are in matrix A. I want my expected counts to go into matrix B. And go down to calculate and select enter. When you do this, again, matrix B is where those expected counts would go. Since we are running a test for this one, we need either the chi-squared, our test statistic, or our p-value, depending on what p-value or what approach we are using. Careful with this because there is an E in your p-value, so be observant of that. So the p-value is 3.37 times 10 to the negative fifth, which again, if you were to move your decimal place 5 times to the left, this p-value would round to 0.0000, which is less than our alpha, which was 0.05. And if we have that our p-value is less than alpha, we are going to reject H naught. So in conclusion, there is sufficient evidence at the alpha equals 0.05 level of significance to conclude that at least one proportion of individuals within each political affiliation reacts differently to the word capitalism. The next test that we have is called McNemar's test for matched pairs. The method used previously were based on independent data for a 2x2 contingency table consisting of frequency counts that result from matched pairs. The frequency counts within each matched pair are not independent, and for each case, we can use McNemar's test for the null hypothesis that the frequencies from the discordant or different categories occur in the same proportion. So in order to conduct the test for a hypothesis regarding the difference of two proportions, dependent samples with a TI-83 or 84 calculator, the samples must be dependent, and F12 plus F21 is going to be greater than or equal to 10. And so these values, these F's that you notice all throughout, we're going to write a little note on the side over here. And so we're going to have a matrix again, but again, it's going to be a 2x2, so it's not very large. So we're going to call this F row 1, column 1. The second one's going to be row 1, column 2. The next one that we have is going to be F of row 2, column 1, and F of row 2, column 2. So when we're going through this, those numbers that are in those same positions correspond to F11, F12, F21, and F22. So step 1 says determine the null and the alternative hypotheses. Definitely something we need to know. The null is going to be the proportions between the two populations are equal, and H1 is going to be the proportions between the two populations are different. So step 2 says select the level of significance. Compute your test statistic. Chi-squared is equal to, and you have to find the absolute value of F of 1, 2 minus F of 2, 1, and then subtract 1 from it, and then square it, and that's divided by F1, 2 plus F2, 1. And then from here it says we're going to calculate the p-value using our chi-squared CDF, and for this, you guys are going to go to second, and we're going to go to vars. And we're going to go to number 8, which is chi-squared CDF. And when you guys use chi-squared CDF, this is going to be our lower bound, our upper bound, and then our degrees of freedom. And our degrees of freedom are going to be 1. It's rows minus 1 times column minus 1, and that just works out to being 1 all the time. Also, we're using a chi-squared distribution, and chi-squared always has a right tail to it. And because of that, that means that your upper bound is going to be 1e99. This is going to be able to calculate the p-value. Once we have this, it says if the p-value is less than alpha, we reject our null hypothesis. And then we're going to state our conclusion. The example below, we will circle and we will work on that one together in class.